Bismillahirrahmanirrahim. This is going to be a second video lecture in a series of lectures that I'm uploading to discuss existence of some irrational numbers and also provide mathematical proof that the square root of 2 is not a rational number. Now, as I have mentioned in the previous video, I will be presenting my lecture in two different levels. One for basic algebra and college algebra level of students, and second one is for a student that they have a bit more maturity in mathematics. So let's get started. This lecture is for the basic algebra and college algebra level. So let's get started for today's lecture. Shall we? Now, we are all familiar with Pythagorean theorem that geometrically indicates about the relation of the sides of a right triangle. And it says that the relation is that the square of the hypotenuse of a right triangle is equal to the summation of the square of the other two sides of that right triangle. Notice that he doesn't say that the hypotenuse of a right triangle equals to the addition of the other two sides. No. Now, as a matter of fact, the addition of two sides of a triangle is always greater than, if triangle can be formed, the third side. They call it triangle inequality. So again, I repeat myself, the Pythagorean theorem talks about relation, a square relation of the sides of a right triangle numerically. All right? Okay, now let me stay out of the way. I have written some stuff so that I can put them on the bulletin board and go over them that way, because I'm presenting for the beginner students this lecture. Okay, then let me zoom this one in, if I may. Now, let me stay out of the way. This is a right triangle, all right? As I already mentioned, the relation between the sides of this right triangle is not that a plus b equal to c, it's a no. So what is the relation of them is that a squared plus b squared equal to c squared. That is the relation of the sides of a right triangle. Now, we have, if, let's say, let me take this one out. If we have a triangle that the A, let's say, is 3 and B is 4, then 3 squared plus 4 squared should be equal to this square, all right? And this square is 25. But if we want C, then we have to look for a number that if we square it, we get 5. Excuse me, if we square it, we get 25. Then what is that number? That number is 5. So this triangle 3, 4, 5 has a lot of application, as a matter of fact, in construction, that I'm going to go over that for demonstration. Now the question comes, I'll go back to this 3, 4, 5 triangle. Now the question from this comes that what happens if the sides of our triangle A is 1 and B is 1? Then the relation according to the Pythagorean theorem is 1 squared, which is 1, plus 1 squared, which is 1, so c squared should be 2. Then if c squared is 2, what is the number that if we square it, we get 2? I repeat myself, what is the number that we square it, we get 2? And there is no such a rational number. As a matter of fact, at the end I say a short story about this subject, what happened for the discovery of a square root of 2. Okay, now let's go to the next one, if I may. Now the next one is about the construction I made. I did mention about construction, that they use 3, 4, 5 triangle for construction. Now look what happens here. Suppose we want two sides, maybe two walls to be perpendicular to each other, all right? So we use that 3, 4, 5 right triangle to do that. It means we can select our unit. Doesn't matter what you select. You can select your unit to be, let's say, your feet, all right? So you put your feet 1, 2, 3, and you put your feet here 1, 2, 3, 4, 1, 2, 3, 4, and then from here to here, you use again your own feet, and you go 1, 2, 3, 4, and you end up here 5, which is a little bit short. A little bit, but in this case, a little bit short. So what you do, you adjust your feet, you adjust this line, so that when you measure, this one is 3, this one is 4, when you use your feet or any other unit that you select for the length, this should be 5 of that units, 1, 2, 3, 4, 5. Then you know that this line and this line are perpendicular. This 3, 4, 5, 3 right triangle is used quite often in building construction, in fact. Now, I have written here for extra is that 3 plus 4 is bigger than 5. They call it triangle inequality. The sides of two sides of a triangle is always larger than the third side. Now, but the Pythagorean theorem talks about relation of a square of the sides. A square of the sides. So I'm emphasizing because it's for the kind of beginner students. Now, let's go to the next one, if you may. The next one is a continuation of the previous one that we talked about. Right triangle. No. Now suppose that, again, my triangle, one side is 1, right triangle, the other side is also 1, then what will be the length of this side? I know the length of this one, a square, is 2. But I don't know what is the number that if we square it, we get 2. And historically, when I was not familiar with irrational number, such a number did not exist for me. But on the other hand, I see geometrically that such a number should exist. So I represent that one with this symbol. This is same as x, you can imagine that, as a square root of 2. And this is a number that if we square it, we get 2. Now, I've written that, all of them that I just mentioned for you. So there is no rational number x such that if we square it, we get 2. But such a number do exist. We can see that because we can see the geometrical representation of that. And then let's select this symbol instead of x to present that number that if we square it, we get 2. Okay, now let's go to the next one, if I may. Now this is our claim. We claim a square root of 2 is a rational number. This is a statement. A square root of 2 is a rational number. It's either true or else false. So it cannot be both. This is a statement. Mathematical statement as we talked about in the previous lecture. Now, if this statement is true, If this statement is true, then according to the definition of rational number, we must be able to find 2 integers. In this case, are going to be positive integers, or let's call them natural numbers. we have to find two natural numbers, p and q, such that p over q is equal to this symbol, the square root of 2. If this is a rational number, we must be able to find such a p and q. So I have written this in Word if you want to look at it. So we are looking for such a p and q so that they can represent the square root of this one. Now the rest of them is very little equivalent algebraic equation that we formed. Now this is equivalent to this. Is that right? We square both sides. If a equals to b, then a squared equals to b squared. But the converse of that is not true. For example, negative 2 squared is equal to 2 squared. Both of them equal to 4. But the converse of that negative 2 is not equal to 2. But here we are not dealing with converse anyhow. So if this equal to this, the square of them are equal. So that is, we call it what? We call it these two are equivalent. Now, we multiply both sides by q squared. We get another equivalent. So this is equivalent to this, is that right? And this is equivalent to this, therefore this is equivalent to this. So this all is equivalent to this. Now we are going to analyze and discuss about this from the point of reason and logic. So let's see now what we can come up. So again, our claim is that a square root of 2 is a rational number. So we went and write it. We are not trying to find p and q to prove our claim that was a statement that a square root of 2 is a rational number. That was the claim, the statement, nothing wrong with that. Now we came up to this. Now let's now analyze this one. This is what we come to the logic of that. Now, the equality I'm talking about is a grade school meaning of equality. So here, in order these two sides of the equality to be equal, the equality is honored, is respected, is accepted, these two must be equal. The left-hand side of this equality is an even number. Why? Because any number, by number I mean positive integers, we are dealing with natural number. Any natural number multiplied by 2 is an even number. Therefore, the right-hand side, which is p squared, must be an even number. But what is p squared? P squared is p times p. It's the same p. It's not twin identical brothers that they look exactly the same, but they have two different personality. Here, p is not two different things, but the same thing, same p. So if this is even, that means in the prime factorization of p squared, we must have even number of factors of 2. You follow me? Even number of factors of 2. So p squared cannot be 6, because p squared is 6. In prime factorization of that is 2 times 3, and one of the p cannot be, if one of the p is 2, the other one must also be 2, not 3. So some numbers like 6, like 8, like 10, like 12, like 14 cannot be p squared. You follow me? As far as the number of, because the number of factors should be even. So there are even number of factors of 2 on the right-hand side. Therefore, we must have even number of factors of 2 on the left-hand side to honor the equality. Is that right? Now, one of the factors is here. Look at that, it's here, 2. So odd number of factors of 2 must come from q squared. Odd number of factors of 2 must come from q squared. But that is impossible. Because q squared is same as q times q. So if one of them has 2, the other one has also a factor of 2. If one of the q has 2 factors of 2 in prime factorization, the other one also has 2 factors of 2 of prime factorization. So it is impossible to get odd number of factors of 2 from this based on this logic. Therefore, what do we conclude? We conclude that the claim that we made, a square root of 2 is a rational number, is a false. And if a statement is false, the negation of that will be true. And the negation of that is that the square root of 2 is not a rational number. Now, let me go to the next one, if I may. Do you follow me so far? Now, I have put them in writing just for extra, because again, I repeat myself, it's for beginner students, and I know some of them have difficulty with that. Now, here, going back from the same, I'm going through this one. 2q squared equal to p squared. I'm analyzing this. Okay, now, p squared is an even number. Is that right? Exactly what I said. I'm just going that one more time. Therefore, what? Therefore, p squared cannot be a number like 6, 8, 10, 12, and 14, as I mentioned. Therefore, p squared, we know that p squared is p times p. Same p, is that right? So the prime factorization of p squared must have even number of what? Of factors of 2. Why? I already mentioned, because if one of them has 1, 2, the other one has also another same 2. If one of them has 2 factors of 2, this one has 2 factors of 2 also, so the number of them will be 4, which is what? Which is even. So this will have even number of factors of 2. I've written for you, for those that they like somehow to take notes. Okay, now, sorry for my primitive equipment, but as long as I convey the message, I'm happy. Okay, now let's go back to this one again. I'm going through the same thing. Now, we know that there are even number of what? Of 2 factors in prime factorization, therefore there must be even number of factors here. One of them is here, I can see that. So odd number should come here. So I have written, since there are an even number of factors of 2 coming from p squared, the prime factorization of that, therefore the prime factorization of q squared must have odd number of factors of 2 in order to match the even number of them, because there is one here. So it should be odd, with this one becomes even, and that is impossible, because q squared means q times q. And again, with the same analogy, with the same explanation, if one of the q's has 1 factors of 2, the other one also must have 1 factors of 2. So there are 2 factors of 2, and one of them is here, makes it 3, but this is odd number of factors of 2, and right hand side we have even number of factors of 2. So that is contradiction to our claim that that a square root of 2 was a rational number, end up to be a false statement. It was a statement, nothing wrong with that, because the statement is either true or false. Now I have some numerical examples that I like. Usually, I encourage in lab class the student to make numerical examples themselves, because they follow with numbers a little bit easier logically. Now, suppose p squared is 2 times 3, because it should be even, and 2 times 3 is an even. But p squared is p times p, is that right? So one of them cannot be 2, the other one be 3. That's absurd. Is that right? That's contradiction. So now we come here. Can it be 4 times 9? Which is here in this case, it was 36. Now here, if p squared is p times p, one of them cannot be 2, the other one one of them cannot be, 4, the other one can be 9, because they are same p. Is that right? They are same p. So whatever this one is, this must also be. So there must be even number of what? Of factors of 2. Now here it is. If one of them has in prime factorization of p, one of the p's have 2 factor of 2, the other one also has a factor of 2, so there are even number of them, 2 and 2. You see that? If one of them say there are 2 to the 5 factors of 2, and doesn't matter what other numbers are coming after that, they are all natural numbers multiplied by 2 to the 5. Same is true here. We are not concerned about that because it doesn't affect our logic. As long as we know this one has 2 to the 5 number of factors of 2, same is with this. So together they will have 2 to the 10 factors of 2, which is an even number of factors of 2. You follow me? Okay then, let me now zoom this one back and say a few words about that. Now, as I mentioned in the beginning, there is a short story about this, interesting story. And that is when the first time square root of 2 was noticed by some people, I don't mention their background, a few thousand years back, because they were only familiar with natural number and rational numbers. And then they tried to keep it secret, because they thought that they have found a number that can be a magical number, or they can have some kind of heavenly relation through that numbers. So they wanted to keep it secret, and one of the members of the team went and discussed that with outsiders, that he was not supposed to do. So they take him to the sea and dropped him to be food for the sharks. This is one of the naive and stupidity of history of mankind, that they have committed this kind of unusual, in a sense, you can call it crime. Okay then, I thank you for watching. I'm going to come back again for this, maybe 1 or 2 more lecture, again for the same level of basic algebra and college algebra. And then the last one or 2, I will be presenting the lecture for a bit more mature students. Okay, then I hope this lecture was beneficial to you, and if you have any comment or suggestion, please do me a favor and mention it in the comment section below, because there is always room for enhancement for a teacher. And also, if you have any subject you want me to give a lecture for, again, mention it in the comment section below. I will be happy to prepare for such a lecture. Some of my lectures here, as a matter of fact, are by the request of the students, and sometimes for the interview they ask me. And I hope that my channel is beneficially. I'm uploading that for the benefit of public, for the benefit of public students, and I'm not expecting any money or something out of it. And I hope that they are positive and effective for you. Okay, then I thank you very much for watching, and as always, I wish you all good health and prosperity, and please stay and remain healthy. So long.